Good morning, SE student. This is your math teacher. Miss you all. Hope you are all safe. Our lesson today is about exponential function and its properties. First of all, we are going to start by solving this activity. The question is, indicate the sign of each of the following without calculation. I notice in the first column that all the terms are negative base. So, if we have here 2, find the sign of each of the following terms. We notice minus 3 exponent 4 gives us a positive number because the exponent is even. So here I have a positive number, while the second one is negative since we have a negative base with odd exponent. Now here this is positive, and here negative. Since the exponent is odd and the base is negative, here greater than 0, which is equal to 1, greater than 0, and here less than 0. What about the second column? I notice here that all the bases are positive, so I notice here this is positive. It doesn't matter if the exponent is odd or even. Since the base is positive, then all the numbers are here what? Positive. Now what about the third column? I notice something new here. We have a negative sign in the exponent, but the negative sign means that I want the inverse of this number. What do we mean by this? As you see here, a exponent minus n equal 1 over a exponent, and so here minus 1.5 exponent minus 4 is equal to 1 over minus 1.5 exponent 4. So this is positive, here positive, we obtain a positive number. Even if the exponent is negative, it doesn't matter. The negative sign of the exponent means that I need the inverse of this number. But if the exponent is even, then the answer must be positive. Yani look like here, I'm not going to multiply negative by negative. Here, minus 1.5 exponent minus 7 is equal to 1 over minus 1.5 exponent 7, which is here I have a positive quantity, here the exponent is odd, I have here negative number, so the answer is negative. So here I didn't multiply negative by negative. This is not correct. So here I have the exponent is even. It doesn't matter if I have here a negative sign, then the answer is positive. The answer is positive. Here the answer is negative. Here since the exponent is odd, and here this number is 1. Also, this is positive. Here I have minus 1 exponent 14 greater than 0, and here less than 0. What about these numbers here? Similarly, but here I notice that the base is what? Positive. So 2.718 equal 1 exponent minus 4 equal 1 over 2.718 exponent 4. This is positive. I notice here that all the terms are positive. Why is that? Since the base is positive, it doesn't matter if the exponent even, odd, negative, positive. Since the base is positive, then the answer is what? Positive. Now, to represent or to find e on the calculator, yes, you took it in the logarithmic function. I'm going to remind you by this. We press shift, then len, we obtain what? E, which is put exponent 1. Then it will be e exponent 1 equal 2.718 whatever, which is a positive number. So here I'm gonna say that e exponent, whatever the exponent, it will be what? A positive quantity. Now this is up to you to solve also this activity to find the values. I started by the first 2 and the last 2. You notice here if I have f of x equal e exponent x, and for x equal minus 100, it will be e exponent minus 100, which gives us 3.72. Don't forget, طبعا here using the calculator. Then exponent minus 44, which is 0.430, then 372, which is a number that approximately equal to 0. Similarly, minus 10, minus 50, e exponent minus 50 for x equal minus 50, e exponent minus 50 approximately 1.9287 times 10 exponent minus 122. What do we mean by this? 0.21 zeros, then 1928, which is also approximately 0. And this is up to you. Use the calculator to find the values, and you should find it. At the end, I noticed here that for e exponent 50, for x equal 50, e exponent 50 equal 5.1847 times 10 exponent 21, which means that I have 51847 followed by 17 zeros, which is a very large number. Also, e exponent 100 approximately 2.688 times 10 exponent 43, which is also a very, very large number. Now, here what we can deduce. Here we can what can you deduce about the possible values of that can be taken by x? I noticed that when I gave x negative number, it's okay. The positive number, it's okay. So that I can deduce that the domain of definition of x is going from negative infinity till plus infinity. What about the value of f of x equal ex when x approach negative infinity? Example here, when x equal negative 100, I notice that the answer it will be approximately what? 0. So I can deduce that limit of f of x when x tends to negative infinity equal approximately 0. So in other words, it's not allowed to write it, but in fact I'm going to say it here. I'm going to repeat it. It's not allowed to write e exponent negative infinity, but if you have e and the exponent is negative infinity, it will be what? 0. Of course, as I said, this is not allowed to write it. Now, in fact, this one here. If we have when x is a very large number, when x approach plus infinity, you notice here when x is very large, x equal 150, 100, we notice that the number or the obtained number are very large, approximately plus infinity. So I can deduce here that also e when x tends to infinity, limit of ex when x tends to plus infinity equal plus infinity. Also here it's not allowed to write e exponent plus infinity, but in fact if you have this form you can write it as e as plus infinity. Okay, I'm going to erase this, but the concept is e exponent negative infinity equal negative equal 0 and e exponent plus infinity equal plus infinity. Now, what about the derivative function of f of x? But before the derivative function of f of x, when you solve this table, you notice that the values of x becomes to be larger. And as you increase the value of x, the value of e of x increases. So what can I deduce about the sense of variation of this function? It will be strictly increasing. Also, I think that f of x equal ex, the exponential function, is the only function that its derivative is the same as the function. So you notice here that f of x equal ex, and its derivative is also equal what? Ex type. Since e equal 2.718, which is a positive quantity, whatever the exponent is, then this quantity is what? Is positive. So since f prime of x is positive, then f is strictly increasing over r. So this is the table of variation, domain of definition from negative infinity till plus infinity. The sign of f prime is always positive, strictly positive, and f of x is strictly increasing, since limit of f of x when x tends to negative infinity equals 0, and here when x tends to plus infinity, f of x equal plus infinity, and this is the representative curve of the exponential function. Here we have some particular points. E exponent 0 definitely equal 1, and e exponent 1 equal e. These 2 points are represented in the curve A and B. Now, here, what about the rules of exponential function? First of all, as you know, ex is strictly greater than 0. Why is that? Because the base is positive, then this quantity is strictly positive. So ex equal negative 2 has no solution, impossible, does not admit. Why is that? As I said, ex is always what? Positive. The power rule, em times en equal em plus n. So if I have e2 times e exponent 6, it will be e8. Or I can write it e3 times e5, e1 times e7. All of them are equal. If I have ex times ex, I can write it e exponent 2x, because x plus x equal 2x. E exponent 2x times ex equal e exponent 3x. Now, e exponent m exponent n, it will be e exponent m times n. In other words, e exponent 2, 5. Here even I can write it as the same as if I have e exponent 5 exponent what? 2. It will be e exponent 10. So ex exponent 2, it's e2x, which is ex times ex. Even I can write it here, e exponent x exponent 2. I can write it e exponent 2 exponent what? X, which is e exponent 2x. Now, e exponent x exponent 3, it's equal e exponent 3x. So I can even write it e2x times x whatever, operations on exponents. You know it from grade 8 and 9, 10, whatever. Now if I have e exponent 3 times radical e, you know, radical e equal e exponent half. And times e and e, if I have it, this is e exponent 1. So we can write in this case e exponent 3, exponent minus 3, plus the exponent which is half, plus the exponent which is 1, and we obtain here e exponent minus 3 over 2. Fifth root of e, of course, fifth root of e equal e exponent 1 over 5. And here I have the second one, e exponent 1, but e radical e, I can in fact write it e times e exponent half. So which is, of course, e is e exponent 1, which gives us e 1 plus half, and we write it like this. Now, what about e exponent m over e exponent n? E exponent m over n equal e exponent m minus n. E exponent 5 over 2 equal e5 minus 2, which is e3. E exponent 3x over ex. I'm not going to simplify by x. No, this is m minus n, which is e exponent 2x. Even here I have e3 over e7. It will be 3 minus 7 e exponent minus 4. If you want, you can even write it 1 over e exponent 4, like this. And 1 over e square equal e minus 2, 1 over e equal minus 1. If I have e exponent minus x, I can write it 1 over e exponent x, like this. Now, as I said, this is the question here. And e exponent minus 2x equal 1 over e exponent 2x. Now, if we want to solve ex equal 2, it is admitted that x equal ln of 2. Of course, a must be, as I said before, positive, since ex equals 0 exists or has a solution when x greater than 0. So if ex equal a, then x equal ln of a. So I can deduce of if ex equal 2, then x equal ln let 2, ex equal 1, then x ln 1, which is equal to 0, and then x equal 0. Ex equal e, here I have in fact 1, then x equal ln let e, which is 1. Ex equal minus 2, as I said before, impossible, since ex positive. Ex equal 0, impossible, since ex is strictly greater than 0. And here, if we have ea equal eb, then a equal b. As example, if ex equal e exponent 3, then x equal 3. If ex equal e exponent minus 2, then x equal e, then x equal minus 2. As an inequality, if ea greater than eb, then a is greater than b. Ea greater than eb, then a greater than b. If so, as example, ex greater than e3, so I can deduce, since they have the same base, so I can deduce that x greater than 3. If ex greater than 3 here, they don't have the same base, then x greater than ln of 3. We know that if I have ex greater than a, then x greater than ln of a, but of course a must be what? Greater than 0. If a less than 0, then ex greater than a. If a less than 0, then x is any real number, then x belongs to R. Why is that? If a negative, then this is a positive quantity. It will be greater than a negative quantity for every value of x. And this is all for today. Thank you.